In this class, we have discussed the true solution together with suspension solution. In this class, we will be discussing the colloidal solution. Let us know the colloidal solution by taking one example. Colloidal solution. Milk is an example of colloidal solution. Starch dissolved in water is an example of colloidal solution. How we will know then that this solution is known as colloidal solution? In order to know it, first of all we will know the property. What are the properties of the colloidal solution? We have seen milk. When we observe milk carefully, then it is not a true solution. Why? Because milk, it seems to be homogeneous. It seems to be homogeneous, but when we carefully observe it, we will see that it has greater amount of fat at certain places at the top and lesser amount of fat at the bottom. It means milk is an example of colloidal solution. But it is not a true solution because the distribution is not uniform. It means it seems to be homogeneous. It seems to be have uniform distribution, but this is not in actually so. It means it is heterogeneous solution. To the next, the property of the solute, the size of the solute of colloidal particle is intermediate between the true solution and the suspension solution. The size of the solute of the colloidal solution is intermediate between the particle size of true solution and suspension solution. We know the size of the particles of the true solution is lesser than 10 to the power minus 9 meter, whereas the size of the solute of the suspension solution is greater than 10 to the power minus 7 meter. That means the size of the solute of the colloidal solution ranges between 10 to the power minus 9 meter to 10 to the power minus 7 meter. It means the size of the solute is intermediate between the true solution and the suspension solution. We will see that this colloidal solution will show Tyndall effect. Tyndall effect, it means when a light is passed through its solution, colloidal solution, then the path of the light is being illuminated and it forms a cone. Why it is so? Because the particles of the colloidal solutions are enough big to scatter the light, which is not in the case of true solution. It means the colloidal solution shows Tyndall effect. The particles of the colloidal solution scatter the beam of light. We will discuss the various property of colloidal solution. Let us know it. Let us discuss the property of colloidal solution. Properties of colloidal solution. What are the properties of colloidal solution? The first is that I have explained you that the colloidal solution, it is actually heterogeneous in nature, but it seems to be homogeneous, as in case of milk, and in case of ink solution, as in case of starch solution. The first one is that the colloidal solution is actually heterogeneous in nature, but seems to be homogeneous. Heterogeneous, it means when we see a colloidal solution, what we observe? We observe that there is uniform distribution throughout the mixture. But when we observe carefully, we see that it is heterogeneous in nature. Clear? The next one, the colloidal solution is actually heterogeneous in nature but seems to be homogeneous. The next is that I have explained to you that the size of the solute of colloidal particle ranges between 10 to the power minus 9 meter to 10 to the power minus 7 meter. That is, the size of the solute is intermediate between the true and suspension solution. The size of solute in colloidal solution ranges between 10 to the power minus 9 meter to 10 to the power minus 7 meter. That is, the size of the solute ranges between the size of solute of colloidal, solute of true and suspension solution. The next one, the size. What is the size? The size is 10 to the power minus 9 meter to 10 to the power minus 7 meter. This size is quite small, and this size, the particle of this colloidal solution cannot be seen by the use of microscope because the size is too much smaller. Only in case of suspension solution we can observe the solute in the solution with the help of naked eyes together with the microscope. The next is that the solute particles cannot be seen through the use of microscope. As we see, the size of the solute is quite smaller, and when the size of the solute is quite smaller, it can pass through the filter paper. It means when we filter the colloidal solution, milk solution, ink solution, starch solution, then they pass through the filter paper without leaving any residue. It means the particles, the colloidal solution pass through the filter paper without leaving any residue. It means the particles of colloidal solution pass through the filter paper, To the next, When we keep the ink solution, the milk, the starch solution, then on keeping they cannot be separate into their distinct layer. It means on keeping it for a longer duration, the solute is not going to separate from the solution. If it is so, then it is quite stable. It means the colloidal solution is stable solution. It means they cannot be separate into their component when kept for a longer duration. The next one, the colloidal solution. Colloidal solution is stable, that they cannot be separated into its component when kept for longer duration. The next one, we know in case of true solution, the solute size is quite smaller, that is lesser than 10 to the power minus 9 meter. It means that particle size is quite smaller to scatter the light falling on it. But in this case, in case of colloidal solution, the solute in the colloidal solution is quite, it means it is somewhat bigger to scatter the light falling on it. That's why they illuminate the path of the light. It means they will scatter the light. It means they will show the Tyndall effect. The next one, the particles of colloidal solution is quite bigger to scatter the light falls on it. That is, they will illuminate the path of light, means they show Tyndall effect. These are the properties of colloidal solution. If we want to distinguish the colloidal solution from true solution, then we have seen most of the property of the colloidal solutions is similar to that of true solution. But one property, that is of scattering the light falling on it, that is used to distinguish physically in the laboratory too, that is used to distinguish the true solution from colloidal solution. How it is so? A colloidal solution scatters the light falling on it. It means it illuminates the path of light, showing Tyndall effect. Whereas in case of true solutions, they will not show Tyndall effect. This is how we can distinguish the true solution with colloidal solution. Let us discuss how we will distinguish the true solution with the colloidal solution. To distinguish true solution with colloidal solution. What is that one? You know, in case of true solution, the particles of true solution are quite smaller to scatter the light falling on it. It means the particles of the true solution does not scatter the light, whereas the particles of colloidal solution are enough bigger to scatter the light falling on it. It means the colloidal solution shows Tyndall effect, but the true solution does not show Tyndall effect. This is how, on the basis of scattering the light by the particles of the solution, we can distinguish them whether they are true solution or colloidal solution. If they scatter the light, then the solution is termed as colloidal solution, and if they are not going to scatter the light, they belongs to true solution. Now, on the basis of the physical state of the dispersed phase and the dispersion medium, that is, on the basis of the state of the solute and the solvent, we can categorize the colloidal solution into various types, such as solid salt, aerosols, emulsions, foam, gel, and so many other substances. We will discuss them one by one. To the next, we will discuss the sol. Sol is formed when solid solute disperses in a liquid solvent. When solid solute disperses in liquid solvent, then it is termed as sol. For example, we have paints, we have ink, we have starch solution. Let us discuss it one by one. The first one, based on the physical state of dispersed phase of solute and solvent. A colloidal solution is categorized as follows. The first one, that is sol. Sol is formed when solid solute dissolves in liquid solvent. Sol is formed when when solid solute dissolve in liquid solvent. For example, ink, soap solution, starch solution, the next one, paint. These are the example of salt. It means in case of salt, which is an example of colloidal solution, they are categorized on the basis of the physical state of the dispersed phase and the dispersion medium, that is the solute and the solvent. The first one is salt. A salt is formed when a solid solute is dissolved in a liquid solvent. We have various examples. For example, we have ink, we have starch solution, we have paint. These are the various examples of salt. To the next, we will discuss the solid salt. Solid salt, it means when a solid solute is dissolved in solid solvent. It means when a solid solute is dissolved in solid solvent, then they form solid salt. For example, we have color gemstones, which is used in rings, that they are of various kinds, such as ruby, such as sapphire. It means when the solid solute is dispersed in solid solvent, it forms solid salt. The next one, solid salt. When a solid solute is dispersed in solid solvent, then they form solid solution. For example, what we have? Color gemstones, that is ruby,